Okay, in this video today we're going to learn how to use our P's and Q's to find the zeros of a polynomial. Now, we already know how to find the zeros when it is a quadratic, by either using the quadratic formula or by factoring. On these polynomial functions, that's not possible because our exponent is of higher degree than 2. So let's say we have the following: x to the third plus x squared minus 4x minus 4. Step one, I'm going to give you a little step-by-step process here. Again, we're finding the zeros. Step one, we are going to find the P's and Q's. Now let's talk about what those are. So the P's, these are our factors, or plus minus factors of the constant, which in this case the constant is -4. The Q's are the factors, again the plus minus factors of the leading coefficient. Okay, so as we look at this problem, our P's would be the factors of 4. So we're going to say that's plus or minus 1, plus or minus 2, and plus or minus 4. For the Q's, that's going to be just, again, it's just a 1 in front, so it's plus or minus 1. So if we're listing the possible zeros, we're going to say that it's going to be plus or minus 1, plus or minus 2, and plus or minus 4. Now that is step one, is just listing the possible zeros. Now step two, we're going to then take and use our graphing calculators. So you're going to use the graphing calculator and go ahead and graph it. And this is going to allow us to determine at least one zero. So as I get my graphing calculator out here and I type this in to my calculator, we've got y equals, I'm going to clear out what's in there, and we're going to do x to the third plus x squared minus 4x minus 4. And let's go ahead and graph that and see what that looks like. So there's my graph. Now I'm going to go ahead and pick out one of the zeros from that. So in this case, I'm going to say that it's crossing here at 2. So I'm going to use 2. Again, we're using the graphing calculator to find a zero. And now we're going to use synthetic division in order to simplify the equation. So I'm going to put in 2, because that's the one I picked from my calculator. Again, remember, it's passing through right here at 2. And then I'm going to go ahead and list my coefficients from my original function. So 1, 1, -4, and -4 is what's going to be listed here. 1, 1, -4, -4. Now I'm going to go ahead and do synthetic. Again, 2 should be since it is a zero, should be a factor. So I go through this process. I bring down 1. 2 times 1 is 2. 2 times 3 is 6. 2 times 2 is 4. And look at that. We get a 0 there. And that's good news for us, because now we've simplified this down to x squared plus 3x plus 2. And again, we can go ahead and set that equal to 0. Now we can take that and go ahead and factor it. So if we factor that, that gives us x and x. We're looking for factors of 2 that add up to 3. That's going to be 2 and 1. And then we can put plus signs in there. Go ahead then and solve that. So it's going to give us x equals negative 2, x equals negative 1. We now have all three of our zeros in this case, and they are all real zeros, 2, negative 2, and negative 1. So really step 3 there is finding the remaining zeros. Now we can make a rough sketch of what our graph looks like. We know from this that we have zeros at negative 2, we have a 0 at 2, and we have a 0 at negative 1. Because this particular function is odd and positive, we know that that's disco right. So it's going to go up here, it's going to go down here. It is going to pass through at each of those points. We also know that looking at the function, that if I put in 0 for x, my y-intercept is going to be down here at negative 4. So I'm going to have a y-intercept down at negative 4. This is, again, I'm just making a rough sketch. It's going to pass through. And there's my last step, is just making a rough sketch using my zeros. So okay, let's go ahead and take a look at a second example, again, where we've got a little higher order here. So we've got a higher order of 4. So step 1, as we said, we're going to find our p's and q's. Remember, p's are our factors of our constant, which is 8 in this case. So it's going to be plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. And then if we list our factors of the leading coefficient, plus or minus 1 and plus or minus 2. That's going to make our possible zeros plus or minus 1, plus or minus 2. I left one out here, plus or minus 1/2, plus or minus 4, and then plus or minus 8. So there's all of our possible ones. Now remember, the next step, we're going to go ahead then and use our graphing calculator and type that in. So I've already, just to save a little bit of time, already typed in to the calculator. When we graph that here, you can see here's what our graph looks like. And we're going to go ahead and pick, in this case, I'm going to go ahead and pick a couple of these, just because we're going to use synthetic twice here. So it looks like it's passing through at 1, and it also looks like it's passing through at 2. So using that, I'm going to go ahead and say, okay, x equals 1 and x equals 2. So when we go down here to our synthetic division to find our other zeros, I'm going to go ahead and put 1 in the box, list my coefficients, which are negative 2, 13, negative 21, 2, and 8. Now as I go through the synthetic, I get negative 2, negative 2, 11, 11, negative 10, negative 10, negative 8, and again negative 8, which gives me 0. Now again, I'm still not at a point where I'm down to now an x to the third polynomial. So we're going to go ahead and do synthetic again, and this time I'm going to put 2 in because I know that's also a 0. Now I bring the negative 2 down, and now I've got negative 2, negative 4, 7, 14, 4, and then 8, and you can see now we're down to a trinomial, which in this case is going to be negative 2x squared plus 7x plus 4 equals 0. Now I can take that and I can go ahead and try and factor that. So when I factor, here's what I end up getting. And I'm going to go ahead and take out a negative first. So 2x squared minus 7x minus 4 equals 0, just to make my factoring a little bit easier. I know that 2x and x are going to be my first terms. We're looking for factors of 4 that are going to pair up with 2 and 1. I'm going to put the 4 here to get me 8. And I'm going to put the 1 here so we can make this positive 8. No. No, we want a negative 7 in the middle. So this is going to be actually negative 4 and positive 1. So now we can do 2x plus 1 equals 0, x minus 4 equals 0. That's going to give us negative 1/2, and x equals 4. So we now have our other two zeros. And again, one of the reasons we use this process or need this process is, one of our zeros is not a whole number. We can't just look at the graph on our calculator and determine that zero. So now we've got all 4 of them. We can go ahead and make our sketch. We know that the y-intercept on this one is at 8. So at least I can 2, 3, 4, 5, 6, 7, 8. So there's another point for us. We know it's passing through at 1. It's passing through at 2. It's passing through at negative 1/2, and it's passing through at 4. Again, this is an even negative graph, so we know that both it's going to end in weak muscles, which means it's going down at the end behavior. We're going up through 8 and then coming back down. And this is just a rough sketch here. Come back down, then we're going back up and then going back down. So it should be kind of an upside down W, or kind of look like an M shape. And again, we can kind of check that. You can see it is a rough sketch, so you can see my graph does need to go up a little bit higher there on the second part of that hump. So again, that's using your P's and Q's to find your zeros. Now sometimes, we didn't do an example of this, but sometimes we get down here to this point, and this may not be factorable. We may have some imaginary zeros like we practiced earlier in the week, and you may have to use the quadratic formula to find your imaginary zeros. Remember what we talked about, if we do get an imaginary zero, it is going to come in a pair. So you'll have a conjugate, you'll have 2 complex if it is a complex zero. So